Hi, I'm Anthony, and this is my video for task 5.3 distinction. This is my testing with MD5, SHA-1 and SHA-256 hashes. So first I had to create a passwords text file. Here I have the 13 different passwords ranging from easy to really difficult in cracking. So as you can see, the passwords get more complex starting from the top, even go down to the bottom. They just range in difficulty. So I created this text file, and I have to go into the directory where it is. Okay, so I'll look in here, and I've created the MD5 SHA-1 and 2 and the SHA-256 hashes before, so they're all in this in the file here, tasks 5.3D. I've generated the hashes. I'll quickly demonstrate using John the Ripper in my previous video. So here is the John the Ripper hashes. One sec, I'll do it here. Okay, so here you can see all the hashes, and I will crack them using the John the Ripper. So we'll do it for the first one, actually MD5. So see, these sessions completed, it's ran, and now show what it's actually cracked. So it's recovered those passwords. I will demonstrate, because you actually wanted me to use Hashcat, so I'll use Hashcat instead of John the Ripper, but it just shows you how quickly the passwords were cracked. I can show you the SHA-256 one. And it's the same thing, so it's still cracking the first couple of easy passwords, but those complex ones still aren't cracked. It is a little bit slower, but not that much slower, because those weak passwords do crack pretty easy. Now I'm going to run Hashcat, so you can see the brute force attack and how fast it takes to try and brute force these passwords, try and get them. So I'll run Hashcat M1400 -A3 SHA-256 with the question mark L, which shows that it's looking for lowercase 8 lowercase characters within the password. So I'll run that. Hashcat's now running. We press S to see the status, to see how long it can take. So I'll press that now. And here it's running. Here you can see the speed is at 33,664. I'm guessing that's guesses per second. This is the progress rate, so it'll take quite a long time to actually brute force this because it's still at 0.63%. So as you can see, it takes a lot of time to crack this, and it's using that much GPU to try and crack it. So it's actually taking quite a while. It's going to take quite a while, a couple hours maybe. So I'll say one more time. Okay, so it's going to take 1 hour and 42 minutes to crack it. So it does take a long time. So I'll just get out of that quickly. And I'll do the Hashcat with a mixed case and digits. So I'll go Hashcat, and we'll just backspace this to too much UD. Yeah, there we go. Okay, so it's running the attack again, and it's looking for a mixture of mixed case and digits within the passwords. So I'll press status, and this one's actually running a bit quicker. It'll take about 15 minutes for it to crack. So I'll stop that now because it shows it's actually a bit quicker. But it's actually because of that, it's because of the key space growth. That's why it's probably a bit quicker at the moment to complete. And lastly, I will run a full ASCII attack. So that's just all the available, obviously, characters in the password. And that will take a little bit longer. Just because it has so much to search for through all those characters. So I'll run that now. And I'll press S again. Here we go. And from these results, you can see that it's actually going to take 6 years and 52 days to complete. So this is as you can see, it's not really practical to use brute force attacks with such complex buses. I mean, you can get it done, but if it's going to take 6 years, I wouldn't do it. I would aim for probably the first two are probably a little bit better and easier, but yes, thank you. That's all for my demonstration. This is my demonstration for using Hashcat to find to brute force attack the passwords. Thank you.